This training video brings some basic outlines of Next One Code project, some basic information about newly developed Triple One component system and its benefits, green policy procurement and how to use a new material. The European furniture sector is a key driver of sustainable growth with a significant contribution to Europe's overall economic health, competitiveness, creativity, innovation, employment and exports. In 2012, more than 900,000 European workers were employed in approximately 126,000 firms, and the sector's production amounted to more than 84 billion euros, with an added value of nearly 30 billion euros. The strengths of Europe's wooden furniture and woodworking industry are well known: an adequate raw material base, its technological lead, its quality and design levels, branding, control over distribution as a result of the proximity of its markets, clustering and networking. Its weaknesses include the costs of labor and raw materials. The major drivers for this market are: shift from solvent to water coatings increases average price, increase in raw material costs drives price of wood coatings, new wood coatings technologies increase application penetration, growth in production and consumption of parquets, increase in production of kitchen and bathroom cabinets, growing renovation and construction industry, and green public procurement. The furniture industry has invested in producing eco-friendly and environmentally safe products. In this regard, some of the strategies put in place by EU manufacturers move in the direction of increasing sourcing of FSC and PEFC wood, chains of custody, investments in research programs for capturing VOCs such as formaldehyde, use of panels made of recycled wood, biocomposite panels, water and bio-based lacquering, or use of bio-based ingredients in foam mattress manufacturing. Right now, there are green trends in the furniture industry. Each of the trends adds something new to the industry and encourages design practices that are eco-friendly. The use of non-toxic and natural materials are two of the trendiest green practices in the sector. During the last decade, the number of requests for implementing environmental management systems has increased. Moreover, the demand of eco-innovative solutions and alternative products for reducing the environmental impact of both furniture products and their linked business activities has been such that technical centers, chambers of commerce, clusters and other social partners from the furniture industry had to create specific departments specialized in eco-innovation and eco-innovative products. These factors evident the new needs created by restrictions in environmental legislation, the release of standard environmental guidelines, and especially the appearance of emerging markets were very demanding with the product sustainability. Green public procurement is defined in the European Commission communication Public Procurement for a Better Environment as a process whereby public authorities seek to procure goods, services and works with a reduced environmental impact throughout their life cycle when compared to goods, services and works with the same primary function that would otherwise be procured. Public authorities are major consumers in Europe, spending some 2 trillion euros each year. By using their purchasing power to choose goods, services and works with a reduced environmental impact, they can make an important contribution towards local, regional, national and international sustainability goals. Green public procurement driving factors are environmental impact, budgetary importance, and potential to influence the market. A piece of furniture can be made out of a large variety of materials. It may therefore be difficult for manufacturers to comply with environmental requirements for all materials used. Coating systems are usually used for the protection and the decoration of the surfaces of products. The products used for surface coatings shall not contain more than 5% by volume of volatile organic compounds, alkyl phenol ethoxylates, isothiazolinone compounds, perfluorinated alkyl sulfonates, phthalates, heavy metals except as a secretive, volatile aromatic hydrocarbons, and halogenated organic solvents that are considered by MSDS to be harmful to health. Next one, called high bio-based content waterborne resin, reduces GHG emissions up to 20% of solvent-borne coatings and fulfills all mandatory GPP requirements. In conclusion, green public procurement will be purchase driver for administration in the next years. Furniture GPP requirements are yet defined and its implementation on progress. Some European administrations are yet subjected to GPP procedures. Next one code covers the full range of GPP requirements, and access to a contract at higher costs compared to standard technologies is possible. The aim of Next One Code is to give the European woodworking and furniture manufacturers a long-lasting solution by developing the first water-based coating system of one-component high-solids water-based coatings. Next One Code will be produced by the European SMEs coating manufacturers due to its affordable chemistry based on seaweed polymers. In recent years, the synthesis of polymers using renewable resources has been widely studied and developed, seeking alternatives to conventional petroleum-based materials. Traditional renewable materials such as vegetable oils or starch are currently questioned as they compete for land and water resources with human and agriculture. Algae are a promising biostock that does not compete with human or agriculture for water or land resources. Algae-based chemicals are expected to be competitive in the short term versus traditional biosources due to the implementation of concepts like biorefineries and the development of algae-based industrial solutions. There are 3 types of seaweeds and they are promising biostock, all of them having polysaccharides. Polysaccharides are themselves compounds ready to use for the synthesis of polymers, but the main objective was the functionalization of the monomers resulting of the hydrolysis of the polysaccharides extracted from the seaweeds. Due to higher carbohydrate content and the nature of sugars available on the brown seaweeds, these have been selected as target species for the extraction of raw material. The seaweeds were collected from beaches and coasts all over the world. To obtain a homogeneous mass, the seaweeds should be firstly dried at moderate temperatures and then milled to obtain a higher surface-to-volume ratio. The extraction of polysaccharides is typically performed by treating the seaweed raw material with hot aqueous or acidic solutions at temperatures ranging from 70 to 100 degrees Celsius for several hours using, for instance, a Soxhlet device. The result was chemical intermediate, that is, any chemical substance produced during the conversion of some reactant to a product. Then synthesis followed and the result of synthesis were three types polyols as target group: polyester polyol, alkyl polyester polyol, and unsaturated polyester polyol. By modifying the monosaccharides with fatty acids of long chain can be applied especially in the synthesis of alkyl polyester. By esterification of one or more OH groups in the monosaccharides with acrylic compounds can be specially applied in the synthesis of unsaturated polyester polyol. Moreover, the acid and sulfonic groups have ionic character themselves and can be used as dispersible groups to include into polymers' backbone. Developed monomers have been successfully integrated into different prepolymers that resulted in stable water dispersions. There were proposed three different synthesis routes for various types of application. All of them are one-component system and most of them get their final properties by physical drying. In contrast to two-component resins, no pot lifetime has to be considered and less waste is expected. The three synthesis routes base on different types of chemistry of the coating resin: polyurethane dispersion, alkyd and alkyd hybrids, as well as polyurethane acrylic hybrids. All resins were based on seaweed monomers. Seaweed monomers can be taken from the saccharide or the oleo part of seaweed components. The first route shown in figure starts with seaweed diols to synthesize a first intermediate polymer called polyester polyol. After conversion with diisocyanate, we will obtain the second intermediate polymer called NCO-terminated polyurethane prepolymer, which can be dispersed in water to get a waterborne coating resin. Second route is about alkyd resins. The synthesis starts with an intermediate polymer called alkyd polyester polyol. In contrast to the route described above, this polymer contains fatty acids. Further modification leads to an alkyd polymer, which can be dispersed in water. An alternative route is the combination of alkyd resin with polyurethane resins. Therefore, the alkyd polyester polyol can react with diisocyanate to get an alkyd polyurethane hybrid. The third route is about another hybrid system of polyurethane and polyacrylics. In contrast to route number 1, we use some unsaturated monomers in the polyester backbone or alternatively in the polyurethane backbone. Afterwards, acrylate monomers will be polymerized in the presence of the unsaturated polyurethane dispersion by emulsion polymerization technique. Seaweed monomers can be used as before in the polyester part or after functionalization as acrylated monomers. Developed monomers have been successfully integrated into different prepolymers that resulted in stable water dispersions. Alkyd and standard polyesters, acrylics, polyurethanes and hybrids have been evaluated according to its performance and features as wood coatings. Specific resin synthesis processes and compositions have been defined in order to integrate bio-based monomer into polymers' backbones. Polyurethane process begins with seaweed-based monomers and continues with synthesis of polyester polyol. The nature of the used monomers defines the final properties of the polyester. The properties of the polyester can be adapted by the used monomers. Diol components are used in excess to obtain an OH-terminated polyester. The ratio of diacids to diols allows to adapt the molecular weights of the polyester polyol. OH groups react with diisocyanate to incorporate the internal emulsifier into the polyurethane backbone. COOH groups are used as ionizable groups which will stabilize the final aqueous dispersion. Synthesis via acetone process. Polyester polyol and DMPA react with deisocyanate to form polyurethane. The isocyanate is used in excess. NCO terminated polyurethane. Ratio of NCO to OH groups allows to adapt the molecular weight of the polyurethane. With the neutralization process, the ionized polyurethane can now be dispersed in water. The NCO-terminated polyurethane chains are connected by the addition of diamine chain extender, which result in further growth of chain length. The removal of acetone is reached at a rotary evaporator. Acetone is removed at reduced pressure and filtered afterwards. Formulating wood coatings can be challenging, given the variety of resins available and the diverse applications in the industry. The key to finding the optimal one-component waterborne polyurethane resin for a wood coating application requires a thorough understanding of two factors: the properties of the resin itself and the critical criteria for the particular end-use market. These two factors are inextricably linked, and as such they must be considered together, not independently, in order to solve this dilemma the best. There are different types of backbones or building blocks for polyurethane dispersions: polyether, polyester and polycarbonate. Sometimes two types of backbones are combined to formulate a polyurethane dispersion. There were prepared two types of resins. The first type of resin was polyurethane, and the second one was polyurethane acrylic hybrid resin, which are commonly used as a film former component in waterborne wood coating formulations. Viscosity is measured by the viscosimeters, but in practice it is assessed from the flow time measured by the EN ISO standard method. We have to choose the appropriate and calibrated flow cap so that the flow time will be between 30 and 100 seconds. The industry is very often still using DIN flow caps, for which the standard was withdrawn. We must be aware that flow time measured by the DIN cap is totally different compared to the one being measured by the ISO cap with the same orifice. Perceval pendulum is a device used for measuring hardness of materials. The pendulum hardness test is based on the principle that the amplitude of the pendulum oscillation will decrease more quickly when supported on a softer surface. Monomer synthesis was performed by Helios. In the first step, monomers extracted from seaweed are pre-polymerized together to form saturated, unsaturated or alkyd-type polyesters. All of these polyesters serve as precursors for the following urethane modification and extension of polymer chains. Additionally, carboxyl functionalized monomer and neutralization agent are usually used in order to overcome thermodynamic incompatibility between polymer and water and to achieve appropriate storage stability. The resin properties have vast influence on the consequential coating performance. It can be adjusted by several parameters. The most important are monomer type, their functionality, and the ratio between functional groups. The next step in resin synthesis route consists of an addition of water in order to obtain dispersion of nano-sized polymer particles in water. Chain extending step is optional and serves to significantly increase molecular weight. Last but not least is the removal of organic solvent by distillation in order to significantly decrease health risk for the end users. The obtained viscous liquids are then used as a binder in coating formulations. Much of what we use in everyday life in some way is made up of oil. Oil is one of the most valuable and popular goods. When the oil is properly cleaned, it can be used for many ways. One of the ways it is to use the oil for the coating production. In recent years, intensive research has been performed for the replacement of raw oil materials input for the production of polyurethane coatings products based on renewable resources. The industry has met the demands of an increasingly regulatory environment by reducing VOCs in formulations. The most economical way of limiting VOC emission is using water-based coating formulations in which water replaces a sustainable amount of the organic solvents traditionally used. Unfortunately, water-based formulations have deficient properties in comparison to solvent-borne ones, primarily as a consequence of using water as a solvent. Poor wood wetting, high grain raising, longer drying times, foam formation, insufficient glossy aspect, and deficient overall resistance. Coatings are of key importance to the final products of our industries. Coatings define the visual aspect and softness of the furniture piece, influencing its effective purchase. Also, the durability and resistance of a coating is a measure of the quality of the whole piece. In recent years, the synthesis of polymers using renewable resources has been widely studied and developed, seeking alternatives to conventional petroleum-based materials. Renewable raw materials are becoming an increasingly important factor in the responsible use of natural resources. Seaweeds are a promising biostock, and solution relies on the modification of seaweed compounds for the development of polymer dispersions. And what are the benefits of new Next One coat technology? Next One coat technology meets the environmental restrictions and customer needs. It is water-based, one-component bio-based system which meets industrial benefits, and those are reducing drying time and have less grain raising, improved wood wetting without the use of surfactant, less foam formation, more glossy final aspect, and increased hardness. Project exploitation is expected to benefit European furniture industry, providing an added value, cost-efficient system which implementation involves VOC legislation fulfillment and cost and processing reduction. New high-performance one-component waterborne reduces waste generation and processing issues associated to two-component systems, and so increasing waterborne coating share in the market. Developed technology will be property of European furniture industry, ensuring an advantageous position for European SMEs industries. To identify how we can improve the performance of the coating industry and what impact of the choice of coating system has, we must firstly understand its current carbon footprint based on raw materials consumed and energy spent during manufacture and application, and transferred to CO2 emissions. Table shows a comparison between the carbon footprint evaluation of both solvent-borne and water-based coating. Footprints give an absolute score for a certain product within a standard methodology framework. We can see that carbon footprint of solvent-borne coatings is 2 times higher than carbon footprint of Next One coat technology, and the carbon footprint of waterborne solvent coatings is almost 1.5 higher than Next One coat coating. Newly produced waterborne one-component coating at this project directly and indirectly influences on the key environmental impacts. Compared to the other coatings, new waterborne solutions resulting in no emission to the atmosphere or solvent-containing waste streams, it is characterized by low VOCs, made of high renewable source with low carbon footprint.
Now, let's say something on the application methods of the coatings to wood. First of all, before we start with the application of a coating to wood, the coating system must be properly prepared and sufficiently mixed. Also, the substrate, that is wood, must be prepared with a great care. Especially it has to be sanded with a sanding paper of an appropriate granulation. Sanding is extremely important because the quality of a wood surface directly influences on wetting of wood by a liquid coating. Sufficient wetting, exhibited by a low contact angle of a liquid coating, is necessary. If wetting is poor, we may later have problems to achieve satisfactory adhesion of a dry film to a substrate. Once we have a properly prepared coating system and the substrate, we can start with the application of the coating to wood. There are various application techniques available. The most simple one is an application by brushing, which is especially popular in the do-it-yourself sector. Then, we have various spraying techniques available. The most important are those based on pneumatic atomization systems. The other very important ones are the airless spraying systems. Some other application methods are also curtain coatings, roller coating, deep and flow coating, and so on. The next step of the coating process of wood is drying or curing. The transformation process of a liquid coating into a solid state, that means into a dry film, can be performed by physical drying, by chemical curing, or most usually by a combination of both methods. Physical drying means that the liquid phase evaporates during the drying process from the liquid coating system. During the chemical curing process, polymers may be formed from oligomers and monomers, or polycondensation occurs, or cross-linking between polymers or prepolymers is carried out. Very often, especially when flat wooden pieces are surface treated, chemical curing is initiated by UV radiation. In this case, we speak of UV curing of the coating. If we want to compare a newly developed coating with the commercial ones, we really have to know its properties very well. There is plenty of characterization methods of the liquid and cure coatings, and we will mention only some, the most important ones, in continuation.
It was developed the first triple system of one-component high solids water-based coating. The main features of alkyd resins are moderate to high solids, high exterior finish and interior stain performance, cost-competitive coating, high bio-based content. Polyester, poly or polyurethane dispersions are suitable for interior and exterior applications, and the main features are moderate to high solids, reliable coating for exterior and interior finish, high performance and aesthetics, high bio-based content. Hybrid acrylic polyurethane dispersions are characterized by the following features: moderate to high solids, moderate cost, high gloss finish, moderate bio-based content.